So, my friends, welcome to this model. In this video, we are going to learn about uh, electrical circuits. So, in this sections, we are particularly going to learn about electrical circuits, understanding electrical circuit, internal resistance, potential dividers. So, before that, you must clear some of the foundation about physics, process and motion, and something about charge and current, energy, power, and resistance. So in this electrical circuit, we are going to learn about three things: series and parallel circuit, internal resistance, potential divider. So before that, there will be outcome: Kirchhoff's second law, conservation of energy, Kirchhoff's first second laws applied to electrical system, to more resistance or more resistors component including EMF. So in general, what is Kirchhoff's law? You may be thinking that what is Kirchhoff's law? Oh, this is very popular thing. As you can see, this. So series circuit. So Kirchhoff's first law, what does it tell us? Let me change my pen to blue, dark blue. Kirchhoff said that this is a particular room and these are the particular numbers of people. So if one person is entering from this side, then at particular instant one person is entering in this door from this side. So it is saying that sum of current entering as an electrical junction will always be the same as the sum of current leaving the junction. Means what is saying that the sum of current means I1 plus I2, which is in electrical junction. An electric junction will always be as the sum of this current leaving the junction. Means what is entering inside the room and that was equal amount of is leaving the room. So resistance, generally what is resistance? Resistance is nothing but the ratio of volt to the current. But instead what is resistance? It is something which gives hindrance to the electrons when electrons are moving in a conductor. So units volt per ampere. See, resistance of 4.8 ohms require a volt of 4.8 volts to produce a current of 1 ampere. So what is the voltage? V is equal to W upon Q. Units are joules per coulomb, energy transfer per unit charge. So as you can see, some calculation in a series. As you can see, it's a 12-volt battery, and you can see some of the resistance which are in series: 30, 10, 60. So what is the resistance of whole circuit? I know we know the formula that R is equal to R1 plus R2 plus R3. So here we will get 30, 40, and it will be 100 ohms. So let's see what we are going to learn. Resistance in a series will be R1 plus R2, and resistance of the circuit is therefore 100 circuits. So current in a series, you can see what is the current flowing through a circuit, the same for all parts of the current. So current is equal to EMF upon R total. So EMF here is the total electromotive force is 12 volt and resistance is 10 ohm. And you can see EMF upon R total 12 volt upon 100 ohms, which is 0.12 ampere. So wait a second, this airplane flying. So potential difference in a series circuit. So we know V is equal to IR. So potential when we put PD across R1, so we get I into 30, which is 3.6 volt, and for R2 we get 1.2 volt, and for R3 we get 7.2 volt. Now what we are doing, we are multiplying it by 3.6. So we wanted to find out power, and power is equal to I upon I into V. We can see now this is power. Now what we are going to do, we are just multiplying respective voltage of this particular resistance. As you can see, now what the Kirchhoff first law states: laws of conservation of charge. The total current flowing into a junction equal to total current flowing out of the junction. Means how many people, means you can understand this is a particular cube, and this particular cube have a particular nice door. Let me draw with a red pen, and there is two people, and here are also two people, as you can see. So now these two people will go at the same particular time, but at same instant these two people will enter in this. So you can see the summation of current will in and out will be always equal. What does the Kirchhoff's second law, the law of conservation of energy? We know that energy cannot be neither destroyed nor be created. It is transferred from one form to the other form. So in any closed loop in a circuit, the sum of electromagnetic force is equal to sum of potential differences. So as you can see here, this is bulbs, and to a bulbs we are attaching a voltmeter, and you can see the perspective 6 volt, 1.3 volt and 4.7 volt. So the energy put into a circuit must exactly match that which leaves the circuit. Means whatever the energy is going in particular circuit will leave the circuit exactly. So Kirchhoff's law. Now we are going to apply this Kirchhoff's law. What exactly is happening here? In a series circuit, the current is same in every position. From Kirchhoff's first law, you know the rate of flow of charge is the same at all points in a circuit. Yes, the charge is not used up. It just flow around the circuit. So as you can say, this is positive, this is negative. So conventionally, the current are moving like this, and electrons are moving opposite to it. I must draw with another, but you can understand it. So as you can see here, you can see it's forming a loop. So what does it happening? What it wanted to guide? A closed loop is one possible path for the current in a series circuit, and there is only one loop, but in parallel there are often several loops. So let's see what they are going to guide us. Something more interesting, you can see that across an every resistor you can see a voltmeter which is kept parallel, and you can see across the battery the E. What is E actually? Let us see what is E. So it is nothing but the energy put into the circuit that must actually match the circuit which leaves the circuit. So this is the electromotive force in. So E is nothing but electromotive force. Here electromotive force, you can see for first diagram you can see the power is shared between component, and total potential difference always add up to EMF. So you can see 5 plus 4 will give you 9. So here if we'll add, then we will get summation of E1 plus E2. So it is what, 9 plus 6. So here in this figure 5, what is the issue? Let us see it clearly. Where there are multiple sources of EMF, the PD across each component must add up to total EMF, in this case 3 volt. As you can see that it is 1, 2.5 and 3. So here will be 3 volt, and in this parallel circuit, as you can see in the parallel circuit, what is happening exactly in parallel circuit, each branch might be different, but the current into each junction must always equal to total current leaving it. So you can see 2.6 when it entering, so it is leaving into 1, it is distributing in between 1.4 and 1.2, and again when it is coming back to this 8, it is again gaining 2.6. So when this 4.2 will come, it will divide into the three sections. First it will divide into 2.8 and 1.4, then it will divide into this 2.8 will divide into 1.2, 1.6, and again when it will come back to this second ammeter, it will be 4.2. As you can see what is actually happening in this case. So here you can see when the voltmeter is 12, here also 12, here also 12, here also 12, 9, 3, 12, 12. So this is 7, and now it is divided. Now it is 5 and 5. Now 7 plus 5, 12, blah blah blah. Multiple loops and adding component. In more complex circuit, it is useful to consider each loop separately. Additional component in series reduces the EMF that is shared between the original component. In this case, the addition of resistance means there is a lower PD across the original component, as 2.0 volt of the 12 supplied has been taken up by new resistor. So this is the summary of the question. So how do we calculate a resistance in parallel circuit? This is also interesting. So you can see this method, computer, television, these all are nothing but they all have resistance, and you can see that 234 the main supply, and you can see thousands ohm something cross, and computer 250 ohms, television 210 50 hertz. Sorry, it's not hertz, it's ohm. What happened to supply current and total resistance and each switch is closed? So it will use generally. So we know that our supply current will be, we know V is equal to IR. So here voltage 230 and divided by 1000 ohms which will get as 0.23 ampere, and including the computer, when we will do such all things, we are getting the particular current 0.92, 1.10 ampere, and heater 4.60 add. Now supply current is now 6.85. So what we are doing, 4.5, we are just adding all this current. More items are switched on, current increases, which imply total resistance decreases. So it is one of the important thing that resistance is inversely proportional current. Yeah. So the total resistance in parallel must always be lower than the smallest individual resistor, because adding current reduces total resistance. So what the second law say, that a PD across R1 equal to EMF of the battery, similar for R2 and RT. So I is equal to I1 plus I3, and we know that E upon R, E upon R, E upon R. So it will get resistance in parallel. As you can see, when we will do, it will become 10 ohms. When we will do this, it will become 13 ohms. It is one of the easy peasy. And this is electrical mechanical toolkit. So V is equal to W upon Q, and most importantly V is equal to IR. What is internal resistance? So here this is small r and this is capital R. So what exactly the difference between small r and capital R? R is inside of the cell and it represents resistance of the cell material. Internal resistance is shown by the two dots at either side. Some diagrams show dotted box around the component. So R1 plus R2, R plus 3. So R total is equal to R plus R. So E is equal to I into R plus R. So we know that since it is this R is inside this particular cell and it represents resistance of the cell material, so R plus R, so E is equal to IR plus IR, and IR is equal to V, and IR we can calculate. So now let me finalize this lecture. Just R total will become R plus R. So we have up till now, we have discussed up till now this very easy topic. So here we are what 15 volt of charging unit, internal resistance and 0.50 ohms and 6 to 10 amperes. What is happening? Actually it is dividing up 6 and 4. So you can see. So these are the particular homework. If you like, please share with your friends and family. So this is Professor Shalabh Tiwari. If you want more topic, please like and subscribe.